Hi folks, well we're way into galaxy season now. Unfortunately it's been typical British weather, so I haven't been able to get out recently. But tonight, fingers crossed, it looks like it's going to be clear. So I'm going to go out and try and image an object I haven't imaged before, and that's M63, the Sunflower Galaxy. So let's see how we get on. Fingers crossed for a nice clear night with no clouds and no technical difficulties. I'm Dr. Ray, and welcome to Astrophotography. So M63, otherwise known as the Sunflower Galaxy, is in the constellation Canis Venatici. It's a spiral galaxy, and it's about 49,000 light years in diameter, and it's about 13 million light years distant from us. It's pretty well placed in the late spring night sky in the northern hemisphere, or from the UK at least, from when it gets dark this time of year, around about 9 o'clock, and you know, it's well placed throughout the night for imaging. It has a very distinctive shape or appearance, hence its name. Okay, so tonight we're having a go at the Sunflower Galaxy. I've got the a.k.a. 2600 MC Pro one-shot color camera on the Esprit 120. I'm also using the a.k.a. 120 monochrome camera for guiding using an off-axis guider. We've got tracking nicely. Yeah, we've got some good tracking at the moment. We're guiding well. It's a total error of about 0.51. Everything looks okay, so let's see how we get on. Well, okay, so far, it's been going not bad. I had a little bit of trouble guiding earlier, but doesn't seem too bad at the moment. Yeah, the subs look okay. Stars look pretty round and focused. Just been out though, and it looks like there's a whole huge big sort of swathe of clouds coming in from the north. So it's just before 11 o'clock, and I was hoping to get a good all-nighter in and maybe get a second target, perhaps the Markarian chain, but looks like the weather is not going to play ball tonight, so I'll keep you posted. Don't know if you can see that or not, but the clouds have rolled in from the north and thwarted the session yet again. So there we have it, folks. The red wall of death. The clouds have thwarted the session, so I'm just going to shut everything down now. But you know, we've got a not bad run. We've got a good 2.5 hours, so hopefully get some nice subs and process it tomorrow. And well, until then, we'll speak later. A bit of an update here, folks. It turns out that this big swathe of cloud that was coming over actually dissipated, so it shows a little bit of patience pays off in the end. It looked like they were in for the night, but they actually cleared. So we're back on guiding, and we've again back to a similar sort of total error of about 0.53, which is not bad. And we're just waiting on the first subs coming through. Let's see what happens. Okay, so here we are in PixInsight, and what I've got here is the integrated run from the session with the Sunflower Galaxy. It was a total of 3 hours, pretty much exactly. Total integration time, 60 subs, 3 minutes each. What I've done here is I have applied dynamic background extraction. I've performed background neutralization, and I've performed color calibration. And then I have performed a minimal mask stretch to make the image non-linear. So that's the result as it stands. So I'm sure you can see at the moment, as things stand, it's a fairly bland, uninspiring image at the moment. So what I want to do is perform a few more tweaks involving color adjustment and saturation and some morphological transformation, etc, etc, and hopefully tease out as much detail and impact as we can in this particular image. So what I've done to do this, I've actually used StarNet a process to subtract the stars from the image. So I've got 2 different images, one with stars and one with just the galaxies. So there's the one with the stars, and here's the one with the galaxy. Now what I've done is I've worked on the image without the stars. I've also applied a local histogram equalization on this to again try and bring out as much detail as I can on the object. And the idea, again, as I said before, to separate the 2 images out is so that anything I do to this doesn't bloat the stars or completely oversaturate them. So what I've done with this, in fact, is again I've performed very, very minimal curves transformation and saturation on it. So I've got a result now that I'm reasonably happy with, and it's time now to recombine them, the 2 adjusted images. So basically put the adjusted stars back with the adjusted galaxy image. I'm going to use pixel math to do that. I'm not going to go into that today, but essentially this is very straightforward. And what we end up with is this, basically. And I'm actually quite pleased with that. There was a little bit of light pollution last night due to the moon, but unfortunately it was the other side of the meridian, so it wasn't too much of a nasty gradient. But what I've got here, which I didn't really notice at the time I was imaging, is this little galaxy down here. It's designated PGC, that stands for Principal Galactic Catalogue 45992, which is about 26 to 36 million light years away. So it's actually a little bit further away. So what I'm going to do next is probably give it a few more tweaks, probably in Photoshop or Affinity, just to adjust the colour slightly, and maybe a little bit of contrast. And there's what I also want to try is using Topaz Labs' Sharpen AI app on this as well. I'll show you what that is right now. So Topaz Sharpen AI is an app essentially that's been designed using machine learning to make decisions on sharpening images. So in other words, it's been taught what is sharp and what isn't sharp, and again it's been taught how to deal with different levels of sharpening and different types of sharpening. So there's two modes you can use it in. You can use it in automatic mode or manual mode, and it's three different types of sharpening, as basically see sharpen, stabilizer, focus. And if you let it decide, again it will decide which method it wants to use, and it will also decide what strength and degree of noise suppression it should have. As I say, you have manual override in it, and it's quite interesting. I've used it before with lunar and planetary imaging, and it's actually worked very well. I haven't tried it so much on deep space objects, so let's give it a try and see what happens. So like I say, let's put everything on its on automatic settings first. So we'll let it make decisions. I'll take a few seconds for it to analyze the frame and make decisions on that. So you can see in the interface here, you've got the original. Now at the moment it's made the decision that the method of processing should be to sharpen, and these are the settings it's decided are appropriate for that for this type of process. Like I say, I'm not too sure what the difference between each of these is, but it does seem to have each one does seem to have a very different effect. So that's it. As you can see now, it's basically carrying out the transformation according to what I think should be done. And well, yeah, I can see a little bit of difference. And what's happened here is, of course, is although the sharpenings, so there's a little bit more detail perhaps being pulled out, but again, what I can see here is at the expense of some noise. Not too bad. Let's see what happens if I change the algorithm. And again, it's analysed the images, so it knows, or it thinks it knows anyway, what. Well, again, arguably is sharpened everything quite considerably, but again, probably at the expense of noise. So let's drill this back and see what the effect is. So again, well, let's just try it just for out of interest. Let's see what happens when we change the algorithm to focus. Well, folks, I'm not too sure. Be interested to know what you think about this. What you think about the differences. It certainly brought out some detail, but again, I'm not too convinced about the increase in noise it's afforded. And I think with this particular algorithm, it's brought out some funny little artifacts. I'm not too convinced that there's any huge benefit of using this app for this particular object, at least, compared to any of the other sharpening tools that are already present in PixInsight. Like I say, I've used this for lunar imaging and planetary to great effect. It makes considerable difference, even after wavelet sharpening. It really does enhance the photographs very well. As I say, for this particular object, not too convinced or observations, put them on the put them in the comments section and I'll read them. You do get a free trial period with this software. Forget how many days, but it's a fairly decent length of time. So obviously, go and play with it yourself, see what you think. So meantime, what I'm going to do is perform a few minor tweaks selective colour or what have you in Affinity Photo, and I'm going to post the final image at the end of this video. So see you in a second. Well folks, thanks very much for watching. I'm quite pleased with the result. I hope you've enjoyed this video. If you have, please consider giving the thumbs up, and also please consider hitting the subscribe button. It doesn't cost anything, it just means that you get a heads up of when more or similar content comes online. Like I say, I hope you've enjoyed it, and we'll see you next time. Meantime, keep watching the skies.
Watch the skies everywhere. Keep looking. Keep watching the skies.